Okay, so my name is Douglas. I work for Nexedi. I'm from Brazil, and I graduated in computer science in the State University of Northern Rio de Janeiro. And I'm gonna talk to you a little bit about how we created a kernel for Jupyter to work with ERP5, and how we are transforming stock movements information into nice pivot tables. So this will be the organization of the talk. I'm going to talk just a little bit about who is Nexedi, what is ERP5, our main product, what is the Wendelin project, what we are doing with ERP5, Wendelin, and Jupyter, and the work we have done with Pivot Table.js, and then I'm talking a little bit about the future of Wendelin and Jupyter. So Nexedi is possibly the biggest open source software publisher in Europe. We have a lot of projects. The biggest ones are SlapOS, ERP5, Resist, which is a very nice one. It provides IPv6 connectivity over IPv4, and it has a very nice routing algorithm, so you will get the best route possible with without packet loss or high latency. We have 2 offices in France. We have 1 office in Germany, 1 in China, and 1 in Japan. And we also have remote workers in Brazil. I am one of them. We have remote workers in Russia and Bulgaria too. And if you want to check all of our projects, you should go to lab.nexedi.com to access our GitLab. And we do mostly Python and JavaScript projects. Nexedi has many different clients of many different industries. So we have customers in the government, in the automobile and airplane industries, and we also have clients with wind power plants. So ERP5, our main product, is one of the most powerful open source ERP5 projects, ERP project, sorry. It runs on any operating system because we have SlapOS, and it builds everything from scratch. Everything that we need is compiled, especially in the machine that we are building. It is built with Python, of course, and it runs any SQL or NoSQL database. If it does not run it yet, you can implement the driver and run it. And the foundation of the ERP5 is the ZOP framework, which is well known in the Python community. It's been here for a while, and it's not going away anytime soon. Then on top of ZOP, we have some third-party ZOP products, and we have CMF, which is the content management framework. And with all these tools, we built the ERP5 framework. And we have a package system in which the packages are called business templates. And this allows clients to have only the features that they need installed in ERP5. So there is no confusing interface with a lot of things that you don't really use. You have only what you need, what you use. And then on top of ERP5, we have the Wendelin X Analytics core, which is 100% open source code. And with Wendelin, we can do out-of-core analytics with all the scientific libraries that we already have and we already know in Python. With little to no modification in the code, you just need to change how you fetch your data because you are fetching data from ERP5. But you can also fetch data in the usual way using CSV files or loading datasets from libraries. And in Wendelin, we have access to, as I said, the data analytics libraries like scikit-learn and LTK, pandas, NumPy, and everything else. And it uses Neo as distributed storage. So we have high performance and reliable distributed storage. It's built on top of ERP5 and SlapOS, of course, and by using them, we have multi-cloud and multi-data center deployment, which gives us high availability and performance when necessary. With Wendelin, so we can use OpenCV and LTK, we can use Blaze, Numba, Pandas, scikit-learn, everything that the scientific community is already familiar with, and we can take advantage of Neo. And we can also use Fluentd to ingest data into ERP5 to be analyzed later. So we can, for example, ingest Apache data and analyze the logs to detect any intrusion, for example. This is very useful. But we were missing integration with Jupyter. And Jupyter is very good and it's widely used. So we wanted to make the Wendelin project play nice with Jupyter. And we did it. And by doing so, we can have rapid prototyping, which makes us much more productive. We can write code really fast, see the output, and the code is executed in the ERP5 context. So we have access to all the nice tools that we built in a lot of years. And we can create code, we create features, we develop, and we can copy and paste this code into ERP5, and it will work. With the Jupyter kernel, we have fast access to famous scientific libraries, so we don't need to install anything on our ERP5, it's already there. We have rich visualization of information. Our Jupyter kernel supports rendering objects as HTML, the same objects as IPy kernel does, and a little bit more. And this is customizable. We can create HTML representation for any class or module that we want. And the Jupyter kernel is also customizable through Jupyter extensions. There are some in GitHub that you can find to modify Jupyter a little bit. And this is the architecture of our kernel. It's a bit different from most of the Jupyter kernels because we are sending code to be executed in ERP5 through an HTTP API. So there are some complications which I will talk about. So we have a wrapper kernel that just send codes to ERP5, wait for the execution, and return the output to Jupyter. And in this ERP5 kernel, We do abstracted syntax tree transformations to ensure that the user is not doing something a little bit nasty or something that we do not want the user to do. And we have this rich object representation as HTML and JavaScript, CSS. We do a little bit of variable injecting to help the user, to give him an environment that will really make him work better. And we also support multiple processes because we do not want just one ERP5 instance to run code. This is not good. So we can have an ERP5 cluster, and we implemented something to help the users build code that will run in many different machines or processors without any issue. And we also needed this because we are storing the user contexts in Zope. So we cannot store functions, classes. And in the scientific community, we also have some modules that store state. This is used a lot in matplotlib for defining some settings for the plot image. So we have something to help in this situation. So this is what the rich object representation that I talked about works. We can handle simple HTML strings, and we can handle objects like the ones from IPython lib.display. They have some, and using this base render as HTML, we can render them in our kernel. And the support for multiple processes comes from the environment object. This environment object idea is to hold a function that will define classes, modules, other functions, and will set any kind of global state that the user needs. And when you execute the next code cell, this setup function is run before it, and you have access to all the variables, modules, and the setup that you did in that function. So as you can see here, I defined a fullbar class and a couscous function, and I wanted to have that fullbar class available as fullbar, but without the capital F, and the couscous function with its own name. And then in the next code cell, I have them available there automatically. I'm sorry. So we do this basically with AST transformers. The environment object is kind of a dumb object. It is there, so just we can detect what function the user wants to store, and then we find the AST node, we transform it back to a string, and then we store it. So we have compatibility with ZODB. And we also need to fix code that the user may want to run, and it may affect other users because of the global state in modulus, for example. So when the user tries to import something, we actually do not do it like a simple import. We will fix it to use the environment object automatically, and we will warn the user about it. Hey, you are doing something that is not cool for us, so we fixed, and you should do it like this in the next time. So when the user tries to import a module, we take that AST node before we run the code, we modify it, and we replace it with other AST nodes, and then we execute the code. So this is how the main function of the import fixer works. You need to define a function, name the visit underscore and the name of the node, and then you can do anything you want. And here we create an empty function. We create a return a dict statement. Then we modify the empty function body, and we created the environment dot define call. Then we create a warning for the user too, and we replace that simple import statement with all these things. And then we saw that our Jupyter kernel was cool and was helping. So we wanted to have a better data visualization, something that is interactive, that the user can change, clicking and dragging and dropping things. So we found pivot table.js. It looks like this. So the user can manipulate the input data and create rows and columns as he wants. And he can change the aggregation function. He can filter data and even create charts, which are very dynamic. So we wanted to integrate this in our Jupyter kernel. And we did, and it worked like this. We get inventory data as a data frame from ERP5. Then I remove some columns that I will not use, and then I use the base handler as HTML with our custom function to create the pivot table UI HTML. It's not as easy as just putting some HTML string there because of our distributed architecture. So we use the portal caches feature of ERP5 to store it in volatile or non-volatile storage, and we can define a custom expire time, so we will not host this frame forever. And this is what it looks like when working with pivot table.js. This is using data from the last slide. It was recorded by me. So it's very easy and fast to customize the table, to change everything and have useful insights from the data. So let's just wait and see. So now I change from a table to a chart, and it plots very good. So a little bit about the future of these things, of the ERP5 kernel for Jupyter. We want to make the kernel run with the restricted Python. We want to have better control of what the user can or cannot do, and which objects from ERP5 he can or cannot access. And we want this because we want to be able to provide anonymous users to access the Jupyter kernel. And also, we may want to patch pivot-table.js to carry ERP5 when you drag and drop columns, when you add and remove features, because we hit some limitations because we are pivot-table.js uses JavaScript, so the data is being featured and processed in the user computer, and the user computer may not have a good performance. So we will have we can improve it by doing this and letting the ERP5 do the hard work. And this is the end already. I'm sorry. I might have skipped something, but I'm a little bit nervous, so forgive me, please.